I don't know if you want to speak a little bit louder, Greg, or maybe move it up a little bit.
All right, maybe I'll just find a way to hold it while I talk. Keep it in front of my mouth.
There you go. We've got the boom mic as well. If you want to, sorry to interrupt. If you're going to be pretty much stationary,
Doesn't matter.
go ahead.
Try this.
That guy really projects.
Right. Test 1. Test 1, 2, 3. Awesome. We'll use this one. Thanks a lot. Hi, well, good morning, everyone. This is what your web vulnerability scanners are telling you. My name is Greg Patton. Thanks for attending. Go over a quick agenda, do a quick introduction, give you some background and observations that I've made through some of my experiences, and then get into the bulk of my topic, looking at some common vulnerabilities that our automated scanners often miss. I'll try to give you a few quick takeaways and ensure everybody is on time for lunch. Good morning again, I'm Greg Patton. I'm the Mobile Delivery Manager at HP Fortify On Demand. Fortify On Demand is a cloud-based security assessment service. We do static and dynamic analysis of all types of applications. My focus has mostly been in web and mobile applications. I'm currently leading the mobile team. And I can address the elephant in the room. Yes, I work for HP and I'm using this MacBook, mostly because I'm doing mobile assessments right now. In fact, working on an iOS assessment in my hotel room. I've been doing application security for a number of years. In fact, I spoke at AppSec USA a couple of weeks ago, and in preparing for that talk, I did some quick research and figured out I attended my first OWASP meeting back in 2007. Some quick background on web vulnerability scanners. Just in my experience in talking with clients and colleagues and friends in the industry, I find that there are so many companies and folks that just rely on just a pure automated scan of their application to determine, to make security decisions, to determine whether they're going to go live or whether they're going to remediate various vulnerabilities. I find there are so many shops that are just simply clicking the scan button in either their static source code scanner or their web vulnerability scanners and trusting those results and using those results to make big security decisions. I think there's a few flaws in that logic, and that's kind of framed the basis for my talk here today. So real quick on vulnerability scanners, I guess the two main types of automated scanners that we see are SAS, or our static tools, which are mostly aimed at source code analysis. HP has the Fortify SCA, static source code analyzer, a number of other check marks, Veracode, a number of other SAS-based scanners out in the industry. The static scanners are very good at finding technical vulnerabilities if they have full purview into source code, and they test the applications while they're not running. And the other type of vulnerability scanners, DAS-based scanners, dynamic application security testing, are testing the applications at runtime, are actually using the applications. In the mobile world, we're actually loading those up onto our devices and running them. In the web world, where the scanners are actually you're running the application from the context of a browser and analyzing the applications as a user would use them. Thank you very much. So as I progressed my career, I found that management just loves scanners, and they mostly love scanners because they're fast and cheap, relatively cheap. They're certainly cheaper than humans going through the same process, and they can certainly automate a lot of processes and do things very quickly, much faster than a human iterating over a web page, fuzzing through all the different input vulnerabilities. I'm involved as a tester. I absolutely love my automated scanners. They're great. They give you a lot of information very quickly, both the static source code and the dynamic scanners. Their first part of a security assessment is typically utilizing those automated tools, getting some good results, and then using those results to kind of narrow my attack. So the basis of my talk here today is talking about a lot of common vulnerabilities, and specifically more web vulnerabilities that the automated scanners miss. Scanners are awesome at finding a lot of technical things. They fuzz through a lot of things that take humans a lot of time to do, but there's a lot of very common and very serious flaws that they miss. So I'm going to walk through several common vulnerabilities that I see every day, that Fortify On Demand sees in a lot of our application testing. I'll start with logic flaws. As opposed to technical flaws, logic flaws are typically caused when developers or the development product teams make assumptions about how users are going to use the application. And they make incorrect assumptions. They assume that users are only going to use an application a certain way, that they're only going to do ABC, and that they would never do ABD or XYZ. So some examples of common logic flaws that we see. The first one was changing an arbitrary user's password. I actually saw this in an application not very long ago. This actually passed a source code audit. There was a change password feature, both for users and admins, that used a common set of change password source code. For the regular users, it had your typical presentation in the web interface where you have provide your email address or username, and then you provide your previous, your previous password, and then you have the two inputs to provide a new password. But on the admin, there was also an admin portal where administrators could change users' passwords, which makes sense. Admins might need to issue a new password for somebody. And on the admin page, the admins just had to enter a username or email address and then type the new password. They weren't required to input the old password. The problem in this application was both sides, the user side and the admin side, were using the same piece of code to execute the change password procedure. So in effect, the users didn't actually have to enter in their previous password in order to change a password. So you can see where this is going. That would enable someone to change somebody else's password. They wouldn't need to know. If I was John, I could change Matt's password simply by typing in his email address and giving him a new password. So very bad stuff. Some other examples of logic flaws, something we see a lot, are kind of bypassing multi-step authentication. We see this a lot more in consumer goods, where we bypass a certain step of a payment system. Often I'm sure you're familiar with a lot of the traditional shopping cart functionality, where we add items to our shopping cart, then we put in a payment process, step 2, and then step 3 is we decide how those items are going to be shipped and where they're going to be shipped. We often find there's applications where we can bypass one of those steps. Maybe we add items to the cart, we skip over the payment part and go right to the shipping part. Logic flaws are, shopping carts are great places for finding logical flaws. Other places where you find logical flaws are just in various hidden inputs. Developers using some type of hidden input that they don't validate. Again, server side, how many found a price for an item. You might find that the price of an item is sent to the back end, and the back end will trust whatever price is input. So if a customer is buying a TV, maybe they instead of putting the $5,000 price in, they put in a $5 price. Or even they put in a negative price, and it gives them a credit. These are all things we see in web applications and mobile applications all the time. So a couple defenses for logical flaws. The main defense is not just relying on your static and dynamic vulnerability scanners. It's actually diving in and thinking like an attacker. trying to walk through the exercise of, not just what is the proper path that a user goes through to execute this function, but what else could a user do? What happens if they go from step A to step D? What happens if they input some unexpected value? How does the application behave? So in defending logic flaws, we look for places where developers potentially made some type of assumption, and we see if we can take advantage of those assumptions. Another area, common area where we see flaws that scanners typically miss is in authentication. So a lot of examples of authentication weaknesses that scanners miss. I've put a couple of them up here: user enumeration, weak password policy, lack of account lockout, insecure password reset, various client-side authentication or multi-step authentication. Multi-step authentication, kind of like the logic flaws we were just discussing. Dive into a few of these, but in short, a lot of these items could be automated. In fact, a lot of our testing procedures for these items involve automation. But typical scanners seem to miss a lot of these things. For starter, a weak password policy, and maybe this is the traditional usability versus security debate. The users want short, simple passwords that they can remember. Security guys want complex passwords. Have to have a minimum 100 characters, uppercase, lowercase, emoji, all kinds of crazy stuff, so that they, attackers could, potentially guess or simply brute force, or use some type of common word list or password list to guess a user's password. Another common flaw we see in applications are user enumeration. User enumeration is when an attacker can determine whether a given username or email address exists in the system. We typically identify this through error messages that the application feeds us back. Like we create a username account or maybe the forgot password page. If I input greg.patton@hp.com, and the application tells me that username does not exist, or there's already a user by that name, you can't create another account. I now know that that account, that username exists in the system, and if I'm attempting to authenticate to the system, I now have one piece of information I need to have. I have a username, and I just need a password. Another thing that vulnerability scanners miss a lot is the lack of account lockout. And this is for good reason. Scanners don't want to lock their sessions out while they're testing. So they often don't test the logout controls on an application. But I'm sure you're all familiar with a lockout policy. After a user attempts multiple invalid attempts to authenticate, the system will lock them out. Typically, kind of 3 to 5. My testing, I tend to at least use a threshold of 10 invalid requests before I flag an application for lack of account lockout. So the next item on the list is password reset flaws. Password reset mechanisms are usually riddled with various items that with various flaws. Some of these we've talked about already, like user account leakage. The password reset. Like this forgot password image I have up on the screen where I put in the name hacker@hp.com. If I click submit, oftentimes those password reset mechanisms will throw back an error message that'll say, a user does not exist in the system. Please provide a valid username ID. So if I'm going through an email list or a common list of user accounts, I can quickly enumerate and figure out what users might exist in the system. Some other flaws we see in password reset mechanisms are actually systems that send out a user's email or send a user's password by email. And this is just doubly bad. Why is this site, a mobile application, sending my password to me unencrypted over the internet in an email? And 2, why do they know my password? If they're sending my password to me, they must be storing it in some type of reversible format or some way that they can access it. Other items we see in related to password reset flaws are predictable reset tokens. Oftentimes, as you're resetting your password, the site might email you a token or a URL that contains a token where you go reset your password. Those tokens could be, my token might be 123. Next time someone clicks the password reset, it's 124, and then 125. I could predict those tokens. I could potentially reset somebody else's password. Also see the flaw where websites fail to expire those tokens. They just live on indefinitely or for a very long period of time. Or if somebody can guess what those tokens are, they can potentially change people's passwords without their knowledge. And a final quick password reset flaw that I see all the time is an auto log on after reset. So I change my password in the system, and then it automatically logs me on. And you might ask why this is bad. And if we find that a lot of these auto login features aren't been included in the application's traditional audit logs. As the user goes to the regular login page, the application logs that the user created a session, has some type of record of the user authenticating. Oftentimes those password reset auto logons kind of bypass that audit logging and potentially leave an entry point for an attacker to authenticate to a system without it being known or logged. So a couple of these authentication flaws can be combined into something that I think is super bad, called account harvesting. And, three of the items I just talked about are kind of the pillars of account harvesting: user enumeration, weak password policy, and lack of account lockout. So account harvesting is where I can harvest a list of valid usernames, passwords that will authenticate to the system. And I have a list, much like those Russian hackers that have been in the news lately. They've harvested a whole bunch of Gmail accounts, so some of these low-level vulnerabilities suddenly roll up into something that's really, really bad. By themselves, each of these vulnerabilities, it doesn't seem serious. In fact, a lot of these items for final demand to be set with a default severity of medium or low. We combine all three of these things together. If we find all three of these items, within an application, it suddenly becomes, a critical severity, a critical issue. I suddenly have a mechanism for enumerating, determining if users exist in the system. If the application doesn't have a weak password policy, chances are a lot of those users have very simple passwords, possibly dictionary words or very simple to guess passwords. And if they don't have an account lockout, I can brute force various word lists. Use the known accounts that I've harvested, use word lists, common password structure, and suddenly get a list of valid users. So a few ways of defending against these. One, if you have all three of these items present in an application, you're really inviting disaster. So a few ways you can defend against this, or you can employ some anti-automation, such as CAPTCHA controls, or something that something that makes it more difficult for an attacker to automate or just brute force through a whole bunch of username and password combinations. Obviously, you can attack each of these vulnerabilities separately. You can ensure that you don't have user enumeration leakage. Make sure that your error messages are generic and don't leak information. Ensure that you have strong password policies and that you're locking accounts out after some reasonable threshold. And finally, you should monitor your applications. Where if you see repeated invalid authentication attempts, from one IP or from over and over into your application, you should have some type of detection control there where you can then take additional actions. The next item on my list of items that scanners don't do a very good job of finding flaws in are CAPTCHAs. And in testing applications, I often find flaws in CAPTCHAs. I think by default, I think we're now programmed to think that, hey, an application has this CAPTCHA control, it must be more secure. There's suddenly this extra step that I have to take to authenticate or to buy my concert tickets or to complete this transaction. But the truth is, a lot of these CAPTCHA controls are just riddled with flaws. A lot of them will actually send the solutions in the responses that get loaded up in your web browser. So if you view source in your HTML or work through the JavaScript, you can actually see the solutions to the CAPTCHA challenge that you've been presented. These often come in the form of hidden input parameters, hidden HTML inputs. Oftentimes, the image name of the CAPTCHA itself, or the CAPTCHA control name, will have the solution, or you'll find it in various comments. Other flaws related to CAPTCHA are, replay attacks. Once I know the solution to a CAPTCHA, there's that possibility that I can replay it over and over again. There's often sites, they may have a CAPTCHA control that might be doing things fairly securely, but they might only have 5 or 6 different puzzles. And if I can, figure out the solutions to all 5 or 6 of those, I can then suddenly replay them or automate automate my attacks. I've also found sites where you can actually remove the CAPTCHA parameter from the request, and whatever logic is validating that on the back end, if it doesn't create whatever false condition that it's looking for, it'll allow you to bypass. So one way I typically test CAPTCHAs is just exclude the CAPTCHA control altogether and see how the application behaves. And surprisingly, I found more than one application where just removing the CAPTCHA has allowed me to bypass. Another area that automated scanners have trouble with is access control and various privilege escalation flaws. Access controls and privilege escalation could be allowing users to access resources that they shouldn't normally be able to access. This could be done by force browsing directly to these resources. Scanners typically miss this. The scanners will spider crawl through your site. If you're doing some type of list-based analysis, you can give it the list of resources, and the scanner doesn't know, should I be able to see this or shouldn't I? It can't make that informed decision. Whereas human testing can allow somebody to go in and say, if I'm customer 123, I change this parameter to be customer 124, and I can suddenly see customer 124's data. I know I have a problem. It's something that scanners miss a lot, but humans can quickly catch up on. That's kind of an example of horizontal escalation, where I'm customer ABC, and if I put in customer ID AED, I now see his orders, his account information, kind of moving horizontally. There's also vertical escalation, where I'm a regular user on the site. Vertical escalation would be that I now have access to more privileged functionality or information on the site, such as admin functionality. So, obviously one way to test this is to test with 2 accounts: the account of a regular user and the account of an admin user, and kind of compare and see what the regular user can see versus the admin user can see, and then actually take that regular user and force browse to all those administrative controls and see, can the regular user actually see this information. So yeah, a couple of testing strategies for these, and like I mentioned, taking multiple accounts and enumerating through the various possibilities of what users can see, taking an admin account versus a regular account, taking a regular account versus an unauthenticated account, and spidering through your site, crawling through your site, manually force browsing the different resources, and seeing what you can see. In addition to various functionalities such as an admin section, I often find that resources are unprotected. Possibly sensitive resources like sensitive PDF reports, sensitive Word documents or other assets that might be on the site. You might, oftentimes, the scanners won't find these because there might not be a direct link to see customer ABC's financial report, but if I type in customer ABC.pdf, suddenly his information is presented to me. So, and another item that scanners have a lot of don't typically do a real good job of are client-side flaws. And this is something as in my mobile application testing that I see just all the time. That we have sensitive information that gets stored on the client itself. So actually stored on your various mobile devices. So, credit card numbers, banking account information, passwords that actually get stored physically on the device. And this is a problem because oftentimes developers not only store this information on the device, but they store it in the worst possible way. They store it unencrypted and just clear text, and this information becomes easy to scrape off. To mobile customers, one thing that I like to tell them is if you have a piece of sensitive information, such as a security number, banking account, passwords, whatever, first ask the question, do I need to store this? And if you don't need to store it, then don't store it at all. Second question, if you do need to store it, you ask the question, can it be stored server-side? Can it be stored on a web server or some other back-end server that I have more control over versus sending it to somebody's mobile device? And the answer to that is no. That there is a real reason that information needs to be stored on the mobile device itself. Then obviously the developers take additional precautions to encrypt that data and not just store it in clear text. Another item we see, particularly in mobile applications, information that's stored in the device logs themselves. So not actually stored in the application sandbox, but stored in the application logs. And in the device logs are super simple for other folks to pull off. And, essentially, if I plug my iPhone into my computer here, I can pull up the iPhone configuration tool and grab the device log. Just real simple. If I have my buddy over here, Conrad, he says, "Hey, I need to charge up my phone real quick. Can I plug it into your computer?" I say, "Sure." And, while he does that, I grab his device log. And the issue with that is we find that applications often store sensitive information, often actual HTTP requests that they're making, oftentimes actual usernames and passwords in the device log itself. And all that information is not sandboxed, it's openly available. Another fun story from the mobile side, we often see that applications kind of fail to harden their binaries. And there will often be hidden secrets within those mobile binaries themselves, and within the actual IPA file for iOS or the actual APK file for Android. My two favorite things that I see very often are various API keys. Find that for whatever reason you're using some service that requires some type of key, and that key will actually be hard-coded within the binary. Then a malicious user can scrape off that API key and then use it themselves. And another item that we see very often are that developers often compile mobile applications in debug mode, and it'll leave a lot of and actually publish them to the store after they've been compiled in debug mode, and it'll leave a lot of their local path information. We actually had a case with a very big financial institution where the application had such paths in it, and we were able to scrape out the developer's name. It had his password desktop / Patton, / mobile development / whatever his local path was. But it's very obvious what his account was. He said, well, that's not a big deal. So I know that his account was Patton. Well, we then took that a step further, did some other internet research. We found that this user account that there was a GitHub user with the same account. Patton, for example, github.com/gpatton. If you don't know GitHub, it's a very popular online source code repository. So this user had an online source code repository. He not only had this GitHub account, but he had publicly accessible repositories. And in his publicly accessible repositories, he actually had the source code to this mobile application. And not only the source code to this mobile application, but the source code to the back-end web server that this application was communicating with, including some of the SSH keys to connect into this company's network. So it seems like a real harmless little flaw, compiling in debug mode, having a user account or the developer's username within a binary. It seems very harmless. That can quickly trickle into certainly more critical flaws. A couple quick client-side items I see in the web world a lot are just sensitive information in JavaScript. A lot of the source code analyzers and even the dynamic web vulnerability scanners have gotten a lot better at analyzing JavaScript, and they can parse through a lot of commonly known strings, such as password equals XYZ. Scanners will really pick up on that information, but often find other sensitive information that gets hidden in there. Very similar to the mobile world, we'll find developer names, developer email addresses, various API keys, just information, general information about the application. We'll also find that in other client-side files, such as Silverlight applications. You take the various DLL files after unzipping Silverlight XAPs. Often find sensitive information that gets sent down to the client, within Silverlight or JavaScript or other technologies. And then, finally, we often see problems with cookies and various session information that tends to contain sensitive information. Always be sure to look at what's coming down to the client. So on the opposite end of the spectrum, another area I see common flaws are in web services. Web services, particularly in the mobile world, are usually a gold mine for vulnerabilities. And they're usually that gold mine for vulnerabilities. In fact, web vulnerabilities, I think, are #1 right now on the OWASP Mobile Top 10 list. And the reason for that is developers make the assumption that users aren't going to navigate directly to those web services. You can have that assumption of web obscurity. And this is true of thick client applications that use web services and various other traditional web applications. We find this just all over the place with mobile applications. Just web services that have all types of functionality that might not exist within the application itself, but exist in that those back-end web services, such as admin functionality, the ability to do more things than just what's advertised within the application. We often find, I kid you not, we often find full SQL statements that are traveling over the wire, which are obviously can be vulnerable to SQL injection flaws. Find all the kind of traditional web vulnerability flaws within web services. And the argument we get from developers is just kind of like a lack of understanding that they just kind of assume that users are always going to use their mobile application through the device. They're never going to monitor their traffic, figure out what that application is actually communicating with, and navigate directly to some of those back-end links. And I can tell you, I probably don't have to tell this crowd that it's very simple. I think there was a talk here in the previous hour about intercepting mobile traffic. It's very simple to do. I'd encourage all of you just to do it as a good exercise to see what type of information travels from your mobile device. You might be surprised at some of the general information that doesn't just go to the application backends, but go to various advertising and analytics services. Information, often your device IDs, information about what operating system version you're running. Really crazy stuff that gets sent around. Encourage all of you to proxy your web traffic, and just as a good learning exercise. It's like I can assure you that the bad guys are doing that, and they're discovering these back-end web services that are often riddled with flaws. So, yeah, and protecting against web back-end vulnerabilities, yes, some of my advice is just remember how easy it is to man the middle web traffic. Assume that the bad guys are using your mobile applications and actually figuring out what endpoints they connect to on the back end, and then assume that they're then manually navigating to those as well. The attackers will come knocking. They will find these back-end web services that you might think are obscured, or you might think that are tough to discover. But in actuality, if you just monitor the traffic, they're in plain view. So to ensure we get everyone to lunch on time, I got a few takeaways. First, going back to the top of my talk, oftentimes management loves vulnerability scanners because they're fast and cheap. Oftentimes, folks think of security as a roadblock instead of as an enabler. And one of the analogies I like to relate to people is kind of the analogy of Formula One race cars. And Formula One race cars have brakes to enable them to go faster, not to go slower. Formula One race cars didn't have brakes. They couldn't approach the speeds that they do. They couldn't travel at 100 plus miles an hour because they didn't have brakes. Traveling at those speeds, we'd have no more Formula One race car drivers. So security should be thought of in much the same way. On the surface, it might think that a lot of our vulnerability checks or penetration tests are roadblocks or some type of hurdle that we have to clear in order to push our application out to production. It's one more step that we have to go through. It's a time delay. But in actuality, if you have a good SDLC and you're employing good security practices while you're developing applications, it can actually enable you to go live with your applications, to push out your applications without worry. Because you know that throughout your process you've been testing for various flaws. It's no longer a roadblock, but something that can allow you to move faster and give you some peace of mind as well. Another takeaway, I invite all of you to kind of adopt the attacker mindset and think like an attacker. It's simply pushing the scan button on your source code analyzer or on your web vulnerability scanner. You're not really thinking like an attacker. You're going through some automated tests, but you're not enumerating through the application to see all that it could do. And this is particularly evident with various logical tech flaws. Should identify various places where developers might make assumptions, where they might assume that a process flows 1, 2, 3. And try it. See what happens if you go 1, 2, 4, or 1, 4, or 1, 3. The old analogy, think outside the box. Don't just think of the way that and how the application is intended to be used, but think of various ways that an application could be abused. Another couple takeaways, just utilize a lot of the resources that are available to you. And I saw that OWASP was one of the sponsors for this event. OWASP is an Open Web Application Security Project, just an awesome organization. They've really been a thought leader in web security for a number of years. They run a number of very awesome projects, and their flagship project being the OWASP Mobile Top 10. The OWASP Web Top 10. They also now have the OWASP Mobile Top 10 and the Internet of Things Top 10. They have a plethora of other resources such as risk rating methodology, attack methodologies, and testing guides for all the various items that I talked about today. Just a ton of great resources out there. Also, invite you to talk to me and any of the folks at HP Fortify on Demand. And we're a cloud-based security assessment service. We do both static and dynamic testing. And not a sales pitch, but if you want to talk Fortify on Demand, you can come see me later. I'll give you a couple links, and I'll try to make these slides available to the conference organizers here as well. At Fortify On Demand, we have a trial program where you can submit a couple various types of applications, as it kind of get a taste of what we do for free. We have a blog where our various testers, including myself, regularly write about various topics in application security. And also invite you to certainly leverage the OWASP resources as well. So I'll be around here the rest of the day if anybody wants to talk to me. I know you probably won't remember my name, so I fortunately have a really easy to remember email alias. Probably remember hacker@hp.com. Anybody has any questions, wants to follow up after the session, catch me online. Feel free to drop me a line, hacker@hp.com. Appreciate you guys having me out here today, and thanks for your time.